Welcome to Access Control List or ACL. Now before we take a dive into the lab, let's go through the basic features of ACL. So ACL, it's an inbuilt feature in the iOS, and that's a kind of a basic level of security which it provides. It's not like a full-blown kind of firewall, but it gives you good features through which you can deny or accept the packets or the services in a network. It provides L3 or L4 level of security. Now, when we say L3, it means that you can either allow or deny from IP to IP, from subnet to subnet, or from network to network. The filtering can be done both on the allow or the deny part. However, on the L4, it means that you can also go ahead and block or deny the service level kind of filtering can be done, which means that on the web service, on the mail service, on the file service, on the remote access, things which work on the TCP and the UDP at the layer 4 in the transport layer, that all can be blocked or allowed. So that's why we also say that ACL is a kind of a packet filtering firewall. Now, ACL controls the packet flow before you switch the packet. That means that if you've got a router, right, and in the router one interface is connected to the LAN and one probably is connected to one more router. Now the interface which is connected to the LAN, that will be kind of the inbound, and from there once the packet comes in, it will switch. There will be multiple interface in the router, and this packet will switch from the inbound to the default gateway to the outbound which it should go through. That interface level also, the packet flow can be controlled. Okay. ACL in itself, when you type down the command of ACL, and that's what we are going to do in the lab, you will see it's got multiple entries. That means ACL can say that, okay, for 1.1 you can block the web, for 1.2 you can block the mail, for 1.3 you can block the file service, and so on. Okay, so multiple entries can be there. And it also assigns a particular unique number for each entry. That number is called a sequence number. Let's say 10, 20, 30, 40. Each of the entries will be having a particular unique number that's called a sequence number. Now, each entry in the ACL will be simple. It can be either a permit or a deny statement. So permit means it will allow, and deny means it will block. Now ACL broadly are of two types. One is called the numbered ACL and the second one is called the named ACL. When we talk about the numbered ACL, that again is divided into two parts. One is the standard ACL, which runs between 1 to 99, and one is called the extended ACL, which runs between 100 to 199. So let's say in the ACL the sequence number is like 10 and the statement, that means that the ACL is a standard ACL in the numbered zone. If it's like 100, that means that it is a extended ACL in the numbered ACL zone. Now, numbered ACL, one more feature is that editing is not possible in the numbered ACL. Now let's talk about named ACL. Again, the named will be divided into two groups like standard ACL and extended ACL. Editing is possible here. Okay, and we are going to check that in the lab as well. Now, one more concept is there, which says that the standard ACL implementation is normally done next to the destination, and the extended ACL implementation is normally done near to the source. Just remember this because once we reach the CCNP level, then you will know that why that is done, why the standard ACL happens at the destination level, and why the extended ACL happens at the source level. Standard, the level will filter only the L3, and the extended will be filtering both L3 and L4, which means including the services as well. Now, ACL can be either inbound or outbound. Inbound means that you have got a router R1, one interface is connected to the LAN, which has got a switch and multiple like computers connected to the switch, and one interface is connected to the ISP or maybe to one more router, right? Now, if you apply the ACL on the inbound interface, which is connected to the LAN, that means your first ACL action will be happening and then your routing will take place. And if you apply the ACL on the outbound interface, which is connecting to one more router or to the ISP, That means first your routing will take place and then your ACL action will be happening. Again, you cannot apply both at the same time. Any of the others should be applied, either inbound or outbound. That depends. Finally, at the end of the ACL, you are going to see there is an implicit deny statement, which means that by default, it's going to deny every other services as well, which is not a good thing, right? So we say that at the end of the ACL, we need to have at least one permit statement which says that, okay, fine, it all is not being denied and a couple of things are allowed as well. Okay, so we'll see all these features in the upcoming lab. Welcome to ACL lab. So this is the topology for the ACL lab, and let me just quickly go through the topology with you. So this side we have got the network 192.168.1.0, and this side we have got 192.168.2.0. This will be the default gateway 192.168.1.254, and here it is 2.254. We have got three laptops here. They are connected to the switch, and we have got one laptop and one server which are connected to the switch, right? Now, our task is to first of all ensure that we block the ping from this particular laptop 192.168.1.1 to 2.1. And again, we block the telnet from 1.2 to 111.2, which is right here, gig01. Okay. And finally block the HTTP request from this laptop 1.3 to the server 2.100. So let's go ahead and first of all, I'm going to configure and load all the laptops and the routers, and then we are going to get into ACL. So for the IP address in the router, let me just go ahead and quickly configure the routers. First of all, we will ensure that all the connectivity is there, and then only then we would do start off. So, all right, we have got interface gig 0/0, where we have got the default gateway. So IP address 192.168.1.254 and 255.255.255.0 and no shut, right? Then we have got interface gig 0/1, which is IP address 1.1.1.1.1, and this is 255.255.255.0, right? No shut, and with that we configure the router. Now, along with that, I'm also going to configure the router with OSPF just to ensure that the routers communicate on the network properly. So first of all, let me give the host name. This is R1, and OSPF is simple. We know the command, so we'll say router OSPF, and of course the process ID. Let's say 100. Network, I will start off network 192.168.1.0 and 255.255.255.0. Of course, area 0. Similarly, we've got a second network which is 1.1.1.0, 255.255.255.0. Again, area 0, right? So that's all about the OSPF configuration, and we are done. Great. Now let me go to the router 2 and configure the IP address along with the OSPF configuration. So here we go. Enable config T host R2, and then we say gig 0/0, and here it is, the default gateway. So IP address 192.168.2.254, 255.255.255.0, and no shut, right? And then interface gig 0/1. Here it is 1112. So IP address 1.1.1.2, and we have got 255.255.255.0. Okay, and we say no shut. Cool. So our R2 is configured, and then I'm going to configure the OSPF here, router OSPF, followed by process ID, and we are going to give the networks quickly. 192.168.2.0, and we have got 255.255.255.0 area 0, and similarly we'll give network 1.1.1.0 255.255.255.0 area 0, right? So with that, we complete the OSPF configuration on the routers R1, R2. Now our laptops, let me check if they are being configured. They are configured statically. Let me just quickly go ahead and make sure that DHCP is enabled on both R1 and R2. And you would have seen the configuration of the DHCP in the lab of VLAN, where I showed how to enable the DHCP on the switch. The similar kind of the configuration is on the router as well. So we will say IP DHCP pool, let's say test is the name, and then I will give network 192.168.1.0, and we'll say 255.255.255.0. Enter, and we have to give the default gateway 192.168.1.254. That's for the R1. We have done it. Now let's check if this picks up the DHCP here. DHCP, and it picked up 1.1. Great. Let's go for the second one. And yeah, no, that is the wrong one. Let me just try it again. That picked up 1.2, and this should be 1.3, and that's 1.3, right? Similarly, I will be enabling the DHCP on this side as well. It will be IP DHCP pool, probably let's say test 1, and then you say network 192.168.1.0, sorry, just 2.0, and we have got 255.255.255.0. Finally, your default router is 192.168.2.254, right? DHCP is enabled, and let's see if this is picking it up. It should be. Okay, we got it, 2.1, great. And what about the server? Okay, that too picked it up. Awesome. 2.2 and 2.2, we can just change this because that is something which I wanted here. Give me 1 second. 2.2. That's so that's the way it should be. Okay. All right. Now, first of all, let's see that our first task is to ensure that we block the ping from 1.1 to 2.1, which is basically from this to this. First of all, we will check if the ping actually works or not. So let's come here and say ping 192.168.2.1, right? Enter. Let's see if that works. Yep, that's working fine. Cool. The second one is about block the telnet from 1.2 to 1.1.2, which is right here. First of all, let's see if the telnet works or not. So for that, we have to go to R2 and enable the telnet there. So let's do that. To enable the telnet, first of all, I will give the command username. And let's say the username I give ABC, and the password I will give, password also I'll keep it like ABC. Press enter. Next command is your line question mark VTY. So I'm going to create the virtual terminals. And at one shot, how many users can actually access the router. So probably I would like to make it 10. So I will say 0 to 9. Okay, if you'd say like 0 to 1, which means 2, 0 to 9 is 10. You're creating the virtual terminals for 10 users. Press enter. And then finally you will say login local, which means though you're going to log in like remotely, locally your username and password should be there. Press enter. And that is how you enable the telnet on R2. Now if I come to 1.2, let's see if the telnet works. I will say telnet and I will say 1.1.1.2, right? And press enter. Let's see what's going on. Yeah, it's working. It's asking me the username, password, and it straight comes to R2. Beautiful. So currently the telnet also works. And the third one is about block the HTTP request from 1.3 to 2.2. Actually, this should be 2.2, not 100. Let me just correct that. All right. So currently I do not have any HTTP page on the local LAN. It's not connected to the network, so public pages will not work here, but I'll just show you the way it works. If you have got a local page, then you can just click on this, go to the web browser here, and if you just type in the URL like 192.168, let's say .2.2, if that is the URL, if you press enter, if you have got a proper page there, it will work out. Here it's going to Cisco Packet Tracer, which is okay, but normally you should be having a local LAN page as well. Okay, so right now it works out. Okay, that's the packet tracer page, but if we go ahead and if we like disable that, block it, then we have to check if that works or not. So this is HTTP, which is basically your web request, right? Now let's go to the first task. Block ping from 1.1 to 2.1. Again, block the telnet from 1.2 to 112 and block the HTTP from 1.3 to 2.2. Okay, if that is the case, now from the ACL standpoint, we know the ACLs are of two types. One is numbered and one is named, right? We'll start with the numbered first. In the numbered, we know that we have got one called standard and one called the extended. Now, if I want to apply an access control list for these three tasks, the ACL that I'm going to use is extended. Why? Because that's going to block or allow the services. It's not about a complete IP to IP or subnet to subnet or network to network kind of thing, right? It's a service like TCP service or a UDP service. So let's see how to do that. First of all, I will go to R1. Okay, and there in the R1, what I will do, I will start going for the extended ACL. Okay, now let's say access list. Okay, and then we'll be pressing question mark and I will say extended, which means I have to pick up a number 100 to 199. Probably I'll pick up 100. Okay, let's pick up 100 as a name there and enter. What I will say deny, right? We're going to deny things. And then in the deny, our first one is the ping deny. Now ping works under ICMP, right? So we are going to deny ICMP here and press the question mark again. It will be showing you from which host to which host. So let's say host 192.168.1.1. I know from here I'm going to deny the ping to the next host, which is 192.168.2.1, right? Again, press enter. And you're going to use the command called echo, which stands for ping. So just type in echo here, and that is your access list done. Similarly, I will be doing the access list for deny for the telnet. And I will say for telnet, we go to TCP, okay? And we will say TCP, again, similar thing, host. And host, I will say 192.168.1.2. From here, I'm going to deny the telnet to, again, host 1.1.1.2, right? Question mark, and you will be seeing EQ, which is going to be equivalent the exact packets question mark, and you can go for telnet. You can also use the port number like 23 there, or probably you can just type in telnet. Press enter. And my third one is access list. Okay, and you will say there 100, and you will say there deny, and this deny is about your TCP again, because your HTTP will be falling under the TCP itself. So you will say TCP again host 192.168.1.3, again host, and you will say 192.168.2.2, right? 2.2 question mark, and there you go for EQ again, equivalent exactly, and go for www. You can also type in 80 there, that's fine. Press enter. So these are the three access list deny which you gave, one for ping, one for telnet, and one for www, right? Now you already know that for the access list, since all are being denied there, the implicit deny is happening, we have to ensure that we permit all the other IPs, okay, or else all will be blocked, right? So we'll say access list, and this time 100, and I will say permit this time, and what I'm going to permit, I will say IP, which is internet protocol, and I will say any source host, right? Again question mark, and again give one more any to any. Anything else will be permitted. Now this was the creation of the access list. Now we are going to check how the implementation has to be done. So if you remember the VLAN, we have seen that the VLAN also we have got a creation command, and we also have got a set of commands for the implementation of the VLAN. Similarly for ACL as well, we have got a set of commands for the creation and a set of commands for the implementation. So implementation, what we have to do, we have to go to the interface. Now here is the logic. Let me pull out marker. Yeah. So we know that the extended ACL will be working towards the source. Normally it is placed towards the source, right? And here your source is what? If I give it to R1, then this will be your source, right? That's the source which is coming towards the router, right? From the LAN. And here it will be inbound, correct? Source and inbound. So let me go ahead and put that command there. R1. Yeah. So I'll be giving int interface G0/0. I'm going to that particular interface itself, and there I'll be typing there as IP access group, and the name which we gave was 100, right? Access list was like 100, and then we say inbound or outbound. We all just have to say inbound, because we have to apply the extended ACL at the source, and here we are going to apply it at the inbound interface. Press enter, and we are done, right? If you want to see the access list, the command is do show access, and you will see all this has been created. Okay, permit IP any. So we have got three ones, like deny the ICMP, deny the TCP, which is telnet, then deny the HTTP request, and finally permit IP any. Now we are going to check, can they ping now? 192.168.1.1. Can I ping to 2.1? Not possible. Destination host not reachable, right? Can I do a telnet? Let's see. So let me go to command prompt and probably do a telnet 1112. Nope, that also is not working. So we saw that both of them failed. Now what about your HTTP? Will it work now? Let's see. 192.168 192.168.2.2. Go. Is it working? No. So basically, our access list is working absolutely fine. There is no problem there. Okay, so that's one way of using the access list, the extended one. And how to remove that? You just have to go to R1, and in the R1 you just have to type in no IP access list, and the list was 100, right? Okay, and press enter. I think I did something wrong there. One second. One moment here. Okay, this was called extended, and then you give 100. Okay, press enter, and it's done. And once it is done, if you come back to your ping, you will actually see if this works. Now it's working, right? What about your telnet? Let's see. Works fine, right? Okay. And what about your web page? 192.168.2.2 works fine. Okay. So that is about the extended ACL and the numbered one, right? Now we are going to do a standard ACL on the numbered. Now, standard ACL is normally used when you are going to work on the filtering of IP to IP or subnet to subnet or network to network. So what I'm going to do here is now I'm going to block 192.168.1.0 from this network. Basically, 1.0 and 2.0 should be blocked from each other. How do we do that? So we will come to router R2, and there now I will do the ACL. So in the R2, let's go to config T, and now we are going to pick up, like I said, our standard access list, which falls between 1 to 99. Now standard we are using because here we do not need any service block. We don't have to block specifically HTTP or telnet or something else. We are going to block the subnet to subnet or the network to network, right? So here I will pick up the number 99, okay? And it's asking me deny. So I will say deny, and I will say 192.168.1.0. This time it's going to ask me wildcard mask. Simple, 255.255.255.0, and if I minus that and invert that, we know how to do it, 0.0.0.255, right? And that's about it. Press enter. Okay. Single command, you also have to ensure that you place the command like permit, otherwise everything else will be blocked if something else is there. Let's say on this router we have got 192.168.3.0 or 4.0. That also will be blocked. We don't want that. We want only 192.168.1.0 to be blocked, right? So permit question mark, you will say any question mark, and that's it. Only one any, right? Now, if I come here, let's say I want to ping this guy, 2.1. Is it possible? Here it is still possible because it is going through this particular, this particular interface. But what about if I want to ping from here? Hold on, ping from this particular command. I want to ping, let's say, ping 192.168.1.254. That also works because the interfaces work when you are applying the standard ACL, which means that anything below the interface will not work. Okay, so here we have just created, by the way, we have not implemented the standard ACL yet. Okay, so just wanted to show you that just creation of the ACL will not help you. So just like the VLAN, we have to create it in first step, and second step we have to implement the ACL. So implementation of the ACL means that I have to go to R2 and then I have to go to the interface. Now interface, which one will be this time? Let me pull up my arrow. So like you saw that just creation of the access list and the deny or the permit will not achieve what you want to do. You have to go ahead and implement that ACL. Okay. Now here, this particular router, now standard ACL has to be applied on the destination. So destination is what? This particular port gig 0/0 will be your destination, and that's your outbound. So you have to go to G0/0 and implement that particular access list, which is 99, and make it outbound, because for this particular interface, the outbound is this guy, right? So let me try it out right now, and then we will check it. Let's come down to R2, and then we will say interface gig 0/0 and IP access group, and we have to go for 99, right? And we have to say in or out, we'll say outbound. Done. Once we are done, let's check how it's working. So if I go to my laptop there, and if I try to ping 2.1, destination host is unreachable. But I want to show you something here. If I want to ping 254, will that work? That will work actually, because even if you block the network, the interface from where the blocking is starting, that default gateway, till that point it will reach out. Okay, but below that point, like moment you say outbound, so below that point all the other devices will be getting connectivity lost to the network. Okay, so that's how it is. Even if you want to ping, let's say 2.2, will that work? Not reachable, right? So that's how it is. So that's about your standard ACL, and on the numbered way. Now if I want to take it off, it's very simple. I will say no access list, the number is 99, or probably I will just add it here, the question mark. Any kind of doubts, press 99, and we are done. Now can I go ahead and ping this? Let's see, 2.1, and it's working. Absolutely correct. Okay, so this basically shows that how the ACL works both for the extended and the standard under the numbered one. Now we will try out the named ACL. Okay, so named ACL, if I want to try out, let me just go here and R1, we will say IP, okay, access list, and it's asking extended. Probably I will choose extended only, and then it tells me extended list number or name. So I will choose a name there. Let's say CCNA is the name. Press enter. And the moment you press enter, you will enter the interface of the name, which is NACL. NACL stands for named ACL. Okay. And here again, I will start with deny. So deny, I will say ICMP. Okay. And extended means that I can actually deny or permit the services, not only the network or the subnet or the IP, but more than that. Deny ICMP, and then it's asking for same commands, host 192.168.1.1. From here, I'm going to deny it 192.168.2.1, and then it's straight away echo, right? That's the first deny. The second one which you can put there is deny TCP host 192.168.1.2, and again host 1.1.1.2, and you are going to type in there as EQ and followed by telnet, right? Done. Third one is again on the HTTP, so it will be TCP only, followed by host 192.168.1.3, and your host will be 192.168.2.2, and you will say EQ again, followed by www, right? So these are the commands which you put. You also have to put the permit there, otherwise it's a problem, like we know. Permit IP, okay, remaining all, any, and any. Done. Now this named ACL has to be configured, okay, which means I will be getting into my interface G0/0, and I know that it's a in. So I will just go ahead and say IP access group question mark word CCNA, right? And I will say it's in, enter. Now once I do this, let's check if my ping works. 2.1, no it doesn't. Let's check if my telnet works. It does not. And let's also check if my web page works. 192.168.2.2, not working, right? Now we have seen that we have got a unique feature when we talk about the numbered ACL. And what is that? We can edit the ACL list. See, I mean to say the named one, not the numbered one. So numbered ACL, we do not have the option to edit it, but in named ones, yes, we do have the option to edit the ACL. And how do we do that? So let's see. If I come to R1, let me go ahead and do show access list. And you will see these are the access list which has been created, right? Now, I wish to create an access list, okay, which will override the telnet one. So for telnet, I have got one list, right? Like 20 is a sequence number. It tells me clearly, deny this particular from this to this, the telnet, and I want to override this. Okay, how do I do that? So the way it works is that the access list, when it is read by the router or in the network, it's read from top to bottom. So anything which precedes this or which precedes this in the top rank, that will supersede the bottom ones. So if I can insert an access list which is between 10 and 20, let's say 15 or 16 or something here, which says like permit TCP and it allows the telnet, you will see that the telnet will start working. Though below that the telnet deny will be there, still the router, when it sees that telnet is 15 number, it will just read that. It will ignore the ones which are below that for the same kind of service. So let's see how to do that. So we have to get into that particular NACL or the named ACL, and for that IP access list and extended. The command name is CCNA is the name, and we have got into NACL, right? In the NACL, you type in 15, enter, and it tells, I will say permit, right? This time permit I will say, and what to permit? I want to permit the telnet. From which host to which host? Again, I know the host numbers, 192.168.1.2, host 1.1.1.2, okay? And I will say EQ, and I will say telnet. Enter. Exit. And let's check how the access list looks like. See, now we have got a command which is entered in between 10 and 20, and that is talking about permit the telnet. And you will see the telnet will start working now because the system reads the first one, okay, deny the ping, it will deny the ping. The second one, permit the telnet, do that. The third one is deny the telnet, it will not read that because whatever comes on top, it will be read, and below for the same kind of the service, it will ignore that. And again, the last one will be read like deny the www, that like that will be read as well. And the last one will be the permit IP any, which is fine. So now if I go ahead and check the telnet, let's see how that's coming up. I will say telnet 1112 and see that works, right? That's awesome, right? So that's how the benefit of the named ACL is there. In the named ACL, you do have the beautiful option of editing that, of inserting something inside which can override the previous commands. Okay. And the way to remove that again will be simple. I just have to get into R1, and in the R1 I will say no IP access list extended CCNA. Enter. And now you will see your all the stuff will be working fine. 2.1, it works, right? What about telnet, which was working? Again, I will check if this works with the deletion of the ACL. Yes, it works. What about your web page? It works again, correct? So that is how the ACL works both for the numbered and for the named list. It's pretty much simple for the CCNA level. We really don't go too deeper, which we will be doing it in the CCNP level. A question that can be asked is that why do we allow or implement the ACL for the extended at the source and standard at the destination? That answer you will be getting at the CCNP level. Right now, just remember that whenever you are talking about the extended ACL, that should be applied at the source, and whenever you talk about standard ACL, that should be applied at the destination. Okay. All right. With that, we came to the end of the access control list lab. Hope you enjoyed it. Thanks for watching. Cheers. Network Address Translation, or NAT. Now, before we get into the key pointers for NAT, let me take you through the topology to understand what is NAT and why do we need NAT. So, this is the topology. Let me quickly pull out my pointer and then we will get into why do we need NAT and what is NAT. So these are the two users who are connected to a switch, all right? And the users are in the local LAN with 10.1 and 10.2 IP address. We have got the switch connected to a router, which is the ISP router. And on one end, the router has got the IP as 10.100. On one end, on gig 0/1, it is having 1.1. That's been connected to the ISP network or the cloud or what we call the internet. And finally, from the internet, we have got the connectivity to the server 3.3. Let's assume that this server is the Facebook server. Now, the use case is that, let's say this particular user at 10.1 wants to get access to this Facebook server at 3.3. So let's see how the packet flow will look like. Now at this end, the source IP will be 10.1, right? And the destination IP will be 3.3, correct? Now the moment the computer knows that 3.3 is not in the same network, it will approach the default gateway, right? And once it approaches the default gateway, you will see that it will go to the gig 0/0 and the router will say, all right, I do not have the 3.3 in my routing table. It will use the default routing because it's a unknown host. So in this case also, the router will see the source IP as 10.1 and the destination IP as 3.3, right? Now, after that, it will go through the cloud, and in the cloud, we have got the mechanisms as MPLS, and through which the packet will flow finally to the Facebook server right here. Once the server accepts the packet, it will give a response to the packet. And in the response, the source IP will be 3.3 and the destination IP in this case will be 10.1, right? Now, once that is 10.1, then it will reach here to the cloud or the WAN cloud, and here it will reach the router at the edge, and the router will say, all right, the source IP is 3.3, great. The destination IP is 10.1, and it will immediately know that it's a private IP. Now the rule as per the networking is the private IPs cannot be routed over public WAN or over the internet. So this router will actually drop the packet because 10.1 cannot be reached from this particular router as it cannot be routed over the public WAN. And that's when this particular user at 10.1 will not be able to access the Facebook server. So that is the problem, right? Now the way to solve the problem is to implement natting. Now let me just take off this drawings. All right. Now when we implement the natting, let's say what happens there and what exactly goes on in the NAT. So once we do the natting, then again from here the router will be, the laptop will be saying, okay, the source IP is 10.1, the destination is 3.3. Now, once it reaches this particular router, the default gateway, what's going to happen is the router will switch the packet from 10.100 interface to 1.1, and it will apply natting on the packet. Remember, natting always is being applied at the router level. So the router will actually convert that private IP to public IP. What it will do is that it will map that 10.1 to 1.1. It will change the source IP and it will say now the source IP is 1.1 and the destination IP is 3.3. Okay, that conversion of the private IP to the public IP is called natting. Now, once that's been done, then this guy will be reaching the Facebook server through the cloud. And once the response comes back from the Facebook server, then your source IP will be 3.3 and your destination IP will be 1.1. Right? Then definitely this particular router here will pick up that packet 3.3 as the source and 1.1 as the destination. It will reach up here to this particular router as 1.1, and 1.1 will look up into the natting table or the NAT table in the router, and it will say, okay, 1.1 points to 10.1. It will just flow the packet to 10.1, and that is how the NAT will work. Okay, now this process of the natting involves two steps. First, the router is going to convert or map the private IP to the public IP. The translation happens. And again, when the response of the packet comes back, then that point of time, again, the public IP will be converted back to the private IP through the natting table lookup. Okay. So this particular way of natting is called static NAT. Okay, where we are doing a 1:1. One private IP is mapping to one public IP, and we are manually doing that. Okay, now let's make it a little bit more complicated. Now what we're going to do here is that, let's say this user at 10.2, this user also wants to take access of the Facebook server at 3.3. Now in that case, what's going to happen is in this end, this user will be having the source IP as 10.2, the destination as 3.3. Okay, and once that packet will reach this particular router, it will convert that 10.2 to 1.1. So basically it will say 1.1 to 3.3. And once that packet reaches to 3.3, again it will come back 3.3 to 1.1. And once it comes back here, then the router will be confused because it cannot map two private IPs to one public IP. Because if this packet comes to 1.1, the router will think the 1.1 was meant for this guy as well and for this guy as well. So whom shall I transfer the packet of 1.1? Okay. Now that's a problem. So in order to solve that problem, what can be done? For every private IP that you want to NAT, you need to have a public IP, which means you need to purchase additional public IP from the ISP, which will lead to more cost. and which also will lead to the deletion of the public IP, because like what we have seen in the subnetting chapter, that we do not have too much of public IPs and we are going to waste the public IPs here. But that is also one form where you can purchase multiple public IPs for the same number of the private IPs on the left hand side of the router. Okay, now dynamic routing is something, let me just point it here, which is many to many, which means that, or dynamic NAT is many to many. So let's say that we have got the private IP. Okay, we have got like 10.1, 10.2, 10.3, so on. Okay, and on the right hand side we have got the public IP. Let's say uh, this side we have got, let me just add it here. Let's say 1.1, then we have got 1.2, we have got 1.3. Now in this case, this will be considered as the pool of the private IP 10.123, and on the right side also this is considered as the pool of the public IP 1.1, 1.2, 1.3. Okay, once this is being done, then your private IPs can pick up any public IP from the pool, which means that your 10.3 can pick up 1.1, your 10.1 can pick up 1.3, your 10.2 can pick up 1.2. Okay, that is called dynamic NATing, where your many private IPs will be mapped to many public IPs automatically. You do not have to do it manually. Okay, now the other thing which I wanted to call out here is, let me just take off the drawings. Yeah. Let's say that we have got servers. So let's talk about the static and the dynamic NAT. Static and the dynamic NAT is mainly used, when you want to host your server, maybe on the AWS or on the Azure. So let's say that you have got 20 servers, okay, on this side. Okay, here we have got like 20 servers. And if you want to access it from outside the firewall, let's say we have got a firewall here and a person is standing in the internet, and from there he wants to access the servers, then definitely the person needs to have the public IPs. Now, how many public IPs the person needs? 20, right? Because each of the server will need one public IP for the person to access. So there is one more way to do that. In the firewall, you can actually create the alias for the interface, which means, let me just show it to you, which means that this gig01 which we have got, you can write gig 0/1.1, and you can point that to 1.1. Okay, then you can write gig 0/-1.2, and you can point that to 1.2, something like this. So you can create the alias and 20 of them on the interface itself, on which the person can connect to the alias interface and get connected to the server IP. That also is a method. Now, the final one is about the really cool one, which is called PAT. Okay, now PAT stands for, PAT stands for port address translation. This basically means if you look at your home internet Wi-Fi, okay, you will be seeing that there are multiple folks who are connecting to the Wi-Fi, which means there is only one public IP, but multiple folks are getting connected. How? And how they're doing that? So I will be showing that to you. Let's say, let me take this off. Let me go to my command prompt, okay? And if I go to my command prompt, let me type in ipconfig. Now this is my private IP, okay, which is shielded from the outside world. I mean, I have got a Wi-Fi router at home through which at least 2-3 folks are getting connected, now, or the devices which are like 4 or 5 which are getting connected to the Wi-Fi router. Now, if I want to know my IP address, let me go to One second here. Um, I just want to open the Google here, and from there we can take it off. So first of all, let me take away this drawings. So there is a command in Google. If you go and type in what is my IP, right? If you go there, then you will see this is your IP address. This is my public IP address, which is being shown to the external world. But I have got multiple internal private IP address on the devices. So good thing is that my internal private IPs are shielded from the external world, right? Now, how that is being done? That is being done through the mechanism called PAT. Now, PAT means that you can have like one public IP address, and PAT will allow 64,000 users for one public IP, which is a huge number. PAT is normally used in your home internet Wi-Fi solution. Okay, so that's about the PAT, and the static and the dynamic NAT I have told you. That's all about the hosting of the servers where they are being used. Um, One more quick thing I would like to show here. Let me go back to command prompt, and there, let me quickly type in. Let's say I will type in a public site. Hold on. I think I have to take off all this annotations, and okay. Let me ping google.com, www.google.com. Enter. Oh, some mistake I did, I believe. I think could not find. Give me 1 second. I'm sure. Okay. Now, once I'm pinging Google, you will see the IP address which is coming up to me. That's a public IP. So I do not have any way to know the inside private IP address in the data center of Google or the server IPs, right? I only can see the public IP of Google, which is being shared with the external world. So that's also one benefit of NAT. You can shield your internal private IPs from the external world. Okay. All right, so that's kind of the basic of NAT, and that is why we need to have NATing done. Now let's go back to our informational slide, and now let's have a look on the different key points of NAT. So NAT, like we have seen, it translates the public IP to private IP, and of course, vice versa, right? Both the ways. It translates between inside local, which is nothing but your private IP, to inside global, which is nothing but your public IP. That's the language which we use in NAT, and be comfortable with the language. In NAT, when I say inside local, it means private IP. When I say inside global, it means public IP. Okay. The plus points of NAT, very simple. Like I said, will hide the server IPs in LAN. They will be shielded from external view, and also will save the public IPs. We do not really have to use, loads and loads of public IPs there, right? And finally, your static NAT, dynamic NAT, your PAT. These are the three types of the NAT. Static NAT is one-to-one mapping, which is one private IP mapping with one public IP, and you have to configure that manually. Dynamic NAT is many-to-many, which means, like I said, the pool private IP mapping with many public IPs, but that will be done automatically. PAT, port address translation, is many private IPs mapping with only one public IP. Okay. And finally, how to check the NAT table at the router R1. Let's say, so all this NATing will be done at the router level itself. Okay, router will do all the job. If you go to the router R1, let's say, you can just type in show IP NAT translation and the details will be there. Again, in the upcoming lab, I will be showing with you how to configure lab and how to verify the commands there for NAT. Now, one more quick thing I would like to show you the concept about the PAT, right? So PAT, I said, many private IPs, but they will be using only one public IP. Now, how it is being done? So let me pick up, let's say again, the same story. The user 10.1 wants to get connected to, let's say, the server 3.3. So the source IP is 10.1 and the server IP or the destination IP is 3.3, right? Now, once that reaches the router, what's going to happen is this router will not only map it, but it will do one more thing there. What it will do is that it will say, okay, this is 1.1, it's been converted, the 10.1 is converted to 1.1. Okay, that is being added in the NAT table as 10.1 is mapped to 1.1. It will also add 3.3 there, which we all know as the destination IP. And what else it will do is that it will also create a small table for source port, or what we call the inside port and the outside port address. Okay, let's say 1024/1024. Okay, something like this it will do, and then it will be traversing to the server, and from the server, when the response comes back, it will check, okay, my packet is meant for 1.1, but that packet will be having the flagging there 1024 or not. Okay, because similarly from this laptop also, if the request goes from this laptop, the router will be converting the address like 1.1. It will map that 1.1 to 10.2. It will say the destination IP is 3.3, and here it will add one more inside port 1025 and outside port like 1025. Okay, so that means that when the packet is coming back from the server, if the flagging is there with the 1024, it will come down to first of all 1024 this one, and then say, okay, 1.1 is mine and 1.1 is mapped to 10.1 in the NAT table. Let's go to 10.1. It will reach there. Okay, similarly, in the other case also, this packet will be coming here, and once the packet comes, it will match up with the 1025, because that packet which is coming from the destination here also will be having the flagging done. Okay, and the flagging will be share 1025 or not. It will just match up with that, then say, okay, 1.1. So 1.1 means it is being pointed in the NAT table as 10.2, and that's how the packets will be going to each of the destination address, uh, and you don't have to add multiple public IPs for multiple private IPs. So that's how the concept of the PAT works. But remember, all this mechanism of adding the port numbers of inside, outside, or internal, external, and the NAT table, they all will be done by the router. Okay. So that's all the concepts about the static, dynamic, and the PAT. And in the upcoming lab, we are going to configure them and we are going to verify them with the show commands. Welcome to NATLab. So in this lab, let's go through the topology first, and then we are going to load the configurations. So we have got two routers on each side of the network, and we have got two switches on each side as well. Uh, to the switch one, we have got three servers which are plugged in, and we have got the IP address 10.1, 10.2, 10.3 here. And on the other hand, we have got a laptop which is connected to the switch. The laptop is having IP address 20.1. Okay. The default gateway on router R1 is set to be 10.1.1.254, and on the other hand, it is 20.1.1.254. The gig01 of R1 is set to 1.1.1.1 IP address, and gig01 of R2 is set to 111.2 IP address. So currently the configurations are blank. So these will be our 4 steps here. Step 1 is about we are going to configure the IP and the routing, which is basically OSPF. And then we are going to check if the reachability is there from 20.1 to 10.1, 10.2, and 10.3. Once that's being established, then we are going to configure static NAT and verify it, and configure PAT-NAT and verify it. Okay, so this topology will be about static and PAT. All right, so let's go ahead and start off our configurations. Very simple. For the routers, I'm going to open a notepad, and in the notepad, let me go ahead and type in en config t. Let's give the host name as r1 and interface gig 0/0, and that will be your default gateway, which is IP address 10.1.1.254 255.255.255.0, no shut, and then we'll go for interface gig 0/1, which is again IP address 1.1.1.1 255.255.255.0 and no shut. And also we can ensure that all the commands are copied to the memory, so do a do wr. Okay, so once all this is done, then we are going to get into router r1, and in r1 we are going to go for the pasting of the commands, and we are done. Once that's been established, then I'm going to make sure that the OSPF is turned on. So router, OSPF, process ID, let's say 100, and then network. I'm going to put 10.1.1.0, and we know it's wildcard mask 0.0.0.255 and area 0. Similarly, I'll go for network 1.1.1.0, 0.0.0.255 and area 0. And that's all about it. We have configured and turned on the OSPF on router R1. For router R2, let me just change the configuration. Host R2 gig 0 is gig 00 for R2 is 20.1.1.254, right? So we'll just change this 10 to 20, and 01 is 1112, so we'll make it 1112, and we are done. Take the configuration, go to router R2, CLI, and there, let's just enter it, paste, done. Once that's being done, then I'm going to again do OSPF router process ID 100. Sorry, we have to ensure that we are, okay, I'm sorry, the command is router OSPF process ID 100, right? And then we will get into network, same thing, 20.1.1.0, wildcard 0.0.255, because every interface or every subnet mask has been taken as /24 and area 0. Then we are getting into network. This will be 1.1.1.0, 0.0.0.255 and area 0. All done. So our router R1 and R2 are completely configured with IP address, and OSPF is turned on. Now it takes 40 seconds for the OSPF to completely load up. In the meanwhile, we are going to check if the server and the laptop are configured. So let's go to server 1, and server 1, let's check it up. Now it's not there, so 10.1.1.1. Again, we are going to keep it /24 itself, 255.255.0, and this will be 10.1.1.254. Okay, that's being done, established. Then we are going to go for 10.2, which is 10.1.1.2, and subnet mask is 255.255.255.0, and this will be 10.1.1.254, right? Similarly, server 3 will be 10.1.1.3, and here it will be 255.255.0, and here it will be 10.1.1.254. Okay, all is done. Now let's go to the laptop, and in the laptop we are going to have 20.1.1.1, and again it is /24, so 255.255.255.0, and now we're going to have 20.1.1.254, right? That is the default gateway. All right, our devices are configured. Now let's check what's happening with R1. I think the OSPF has been loaded now. Loading done, it tells. So we'll see do show IP route. Let's check all the routes here. And yes, it's going up. We are seeing the OSPF there. We can also check the neighbors. Do so IP OSPF neighbor, and you will see OSPF is showing up. Fantastic. Let's go to router R2. R2, we are going to check do show IP route. It's showing up completely, and do show IP OSPF neighbor. That also is showing up properly. Cool. So our step 1 is completed. IP and the routing configuration is done. Now step 2, check the reachability from 21 to all the 3 servers. So I will go to 21 and command prompt. Let's check one by one. Ping 10.1.1.1. Let's see if that works out. And that's working out, right? So super 10.2. Let's check the second one. Also check that the reply of the packets are happening from 10.1 itself, 10.2 itself, right? In both the cases. So 10.1 it is coming, 10.2 it is coming. Once we establish NAT, you will see these will change. And 10.3, okay, 10.3 is reply from 10.3 itself will be coming up. Okay, that also works absolutely fine. So our step 2 is completed. The devices, they are having the connectivity. Now step 3 is to configure the static NAT. Now static NAT, we know it is the mapping of the private IP to the public IP, 1:1, correct? So we have got 3 servers with 3 private IPs, and I'm going to configure them with 3 public IPs. Let's say that I have purchased 3 public IPs, let's say 55.1.1.1, 55.1.1.2, and 55.1.1.3. And we are going to configure it in such a way that these 3 private IPs 10.1, 10.2, and 10.3 will be mapped to 55.123. All right. So the configuration of the NATing will be happening in R1, always in the router. Let's go to router, and the command will be IP NAT. So again, prior to we get into the configuration, when it comes to VLAN or ACL, okay, the configurations are divided into 2 parts. The first part is creation, and the second part is implementation. So here our first part will be to create the configuration for NAT, which can be done in the configuration level itself, the config level of the router. And then we are going to implement the NAT. That will be happening on the interface level of the router. So configuration level, IP NAT, let's go for inside. Why? Because we are going to do it on gig 0/0, this particular interface itself. That's why the NAT will be inside. Okay, and question mark, then it says source, which is the translation of the source address. Of course, source will be there. Then it says list or static. Now list stands for dynamic NAT, and here we are going to do the static. So let's go for static. Question, inside local IP address, which is basically your private IP, right? So 10.1.1.1, that is the first address, question mark, and inside global IP, that is something which I have purchased from the ISP. So 55.1.1.1, right? Anything else? Done. That is the implementation command for 10.1. Similarly, I'll be doing it for 10.2 as well, 55.2, and I will make it 10.2. Okay. And similarly, I will be making it for 55.3, and I will making it for 10.3. That's about it. These are the implementation, these are the creation commands for the NAT at the configuration level of the router. Now we are going to implement them. Implementation has to be done in both the interfaces of the router, gig 00 and gig 0/1. So 00 is inside and 0/1 is outside, right? It is the outside the network, and 00 is inside the network. So if I get into interface gig 0/0, you will just type the command IP NAT question mark. It will ask you inside or outside. Definitely inside. Enter. Similarly, gig 0/1. This is inside or outside. This will be outside 0/1, right? Enter. And that's it. This is the implementation of the static NAT. So we have done with the creation commands of the static NAT and the implementation commands of the static NAT in the interface level of the router. Now let's go back to the laptop and let's check it how the ping commands work now. So I will say ping 10.1, let's say. And are you seeing the reply is coming from 55.1, right? So your inside IP address is hidden. The external world is only going to see the public IP, right? Again, 10.2, that is 55.2. Cool. And 10.3, that is 55.3. That's how the static NAT is established. And if you want to check out with the show command, we can just directly go there and type in do show IP NAT translation and just enter. And that is the NAT table in the router. And you will see that all your 10.1s, they are being mapped to 55.1s. All your 10.2 are being mapped to 55.2. All your 10.3 are being mapped to 55.3. Awesome, right? So that's all about your static NAT. Now let's get into, so our step 3 is done. Now we are going for configuration of the PAT and to verify PAT. Now PAT means, or port address translation means that for multiple private IPs, you are going to use only one public IP address. Basically many is to one. So for multiple private IPs, you're going to use only one public IP address. Okay. So before doing PAT, I would like to make sure that we take off the static NAT from the router. How do we take it off? Very simple. I'll go to the router, and these commands which we gave, this IP NAT inside, I will just go there and I will say no IP NAT inside. Okay. Enter. 55.1, I'm done. Similarly, I'll be doing for 55.2 and 3. So 2, I will say no, and 3 also will be saying no. So your static NAT is gone. Now I'll be taking off these 3 servers, and instead of them, I will plant 3 computers there. Okay. So let me go ahead and just plug this out. And yes, all taken. And let's plug on some computers. Because when it comes to the port address, sometimes the servers will not work out in packet tracer. So it's good to have the laptops connected. That's what I've personally seen in the past, that sometimes it fails with the server. So let me go ahead and just do the connectivity from laptop to the switch. And let's establish the IP address. Again, this will be 10.1.1.1. This will be 10.1.1.2. And this will be 10.1.1.3. Okay. Once that's been done, now this time I'm not going to go to each of the laptop and to configure it statically. What I'm going to do, I'm going to enable DHCP on the router. Very simple. It will be automatic. So DHCP, the command is very simple. IP DHCP, and you say pool and give a name, like let's say pool 1. Enter. Network. Network will be 10.1.1.0. and you give the network mask 255.255.255.0. Enter. You also give the default router 10.1.1.254. Done. Brilliant. So once DHCP is over, then you can go to each of the laptops and you can just use the DHCP to get the IP address, subnet mask, and default gateway automatically. So it's coming up here, and this will be coming up here as well. Yep. And this will be coming up here as well. Super. So all have came up. Now we are going to establish PAT. So for PAT, again, we are going to do the configuration commands on the router. Now for PAT, our first step will be to ensure that with the help of a ACL, okay, we are going to permit the 10.0 network or 10.1.1.0 network to this interface. And then we are going to establish PAT. Okay, so let me go ahead. PAT will be, the configuration will be IP access list, and you can go for extended. The extended for the ACL works for both L3 and L4, and standard works for only L3. We can use the standard as well because we are going to do in the L3 level, but just for the sake of it, I will be using the extended because it has got the power of L3 and L4 both. Okay, extended, it asks a name here. I will give a name to the ACL, which is CCNA, and that's it, we are done. Once we get into the NACL or the named ACL configuration, then I will use permit command. Permit, and permit what? Permit your IP, right? Internet protocol. And I will say permit IP question mark source address 10.1.1.0. It's asking the wildcard mask, which is 0.0.0.255 because it's /24 question mark. Destination address, I will give it any, okay, because we just want to use that. So I will see any here, and question mark, you don't have to give the DHCP, any. That's it, done. Okay, now once that's being established, okay, because the ACL has been created now to permit the 10 network to any of the destination IPs, now we are going to go for our NAT. So IP NAT, okay, and you will say inside, because we are doing it from the 10.1.1.0 network or the gig 00, and source, of course, list or static. This time it will be list because we are going with the dynamic, right, or the PAT actually. And word, of course, CCNA, that is the access list name for the local address. Then we are going to go to interface. Okay, interface what? Now, which interface would you like to establish the PAT? Here, right, gig 0/1, because this network you're going to allow through ACL, and on this one you're going to establish the PAT, gig 0/1. So I will say gig 0/1, okay, question mark. Now, overload is the command which has to be used to make sure that your port address or your inside port and outside port, okay, they are established. Okay, in packet tracer I have seen without using the overload also the PAT works. That can be a kind of bug there, but in real life you have to use the overload command, which will ensure that not only the IP to the global is mapped to the private IP in the local, but apart from that, it will also establish the fact that your port numbers of inside and outside are generated. Okay, so overload, enter, and that's all about PAT. Your PAT is being established. Once PAT is being established, then you can go to this laptop and let's check up how the command works. Let's say ping 10.1, and you will see the response is coming from 1.1.1.1. Look at that. Okay, and what about the 10.2? It's going to use the same 1.1.1.1. That is why PAT, we say that we are basically using one public IP to get in connection with multiple private IPs. 10.3, same thing. Pretty cool, right? All right, so that's all about PAT, and with that we came to the conclusion of the step 4. I can also share with you how the PAT looks like. If I want to check out the verification command, do show IP NAT translation. Okay, if I press enter, now this is having your basically these are your port address there, the .25, 26 and all that, and you will see all the 10.1s, they are established to 1.1. All the 10.2s here, they are being mapped to 1.1 again. All the 10.3 also are mapped to 1.1. What is going to differentiate them is that all the port numbers which are at the end, like colon 25, 26, 27, these are all going to differentiate them, that 1.1 will place them to which of the local private IP, and not to confuse. All right, with that, we came to the end of the NAT lab. I hope you enjoyed it. Thanks for watching. Cheers. Wireless. So let's go through the key points of wireless. Now, wireless is basically a contention-based mechanism, which means that only one device is allowed to talk at one point of time. And wireless also has got the feature called CSMA-CA, which is collision avoidance, and that will help to prevent collisions when the Wi-Fi devices are talking. Now there is something called ISM band device, which means that industrial, scientific, and medical band devices, and the Wi-Fi, they need to maintain the distance from them due to the frequencies, like microwave ovens and so on. And if you keep them close or on top of them, then they will not work properly. In Wi-Fi, the frequency are of two ranges. One is 2.4 gigahertz and one is 5 gigahertz. Now in 2.4 itself, it's been divided into 14 channels, and the three usable channels, or the non-overlapping channels out of the 14, they are 1, 6, and 11. In the 5 gigahertz range, it's been divided into 36 channels, and 25 of them are usable, which are called non-overlapping channels. Now, when you want to set your wireless access points or the APs, you have to make sure that you set them up with different channel numbers. So let's say you have got one, and if you set them all the four, like all the four APs with equal channel number 1111, and in the center you keep a user, the user will be confused, from which AP to take the frequency. So you should keep like one, then probably 6, then 11, and like that, in a segmented way, so that the end user who is getting connected gets connected to 1 or 6 or 11, and then 1, 6, 11, and so on, but not like all the four ones in one shot. Okay, because if you keep all the four APs and in center is the end user, then the end user device might be confused from which channel to pick up the frequency or the signals. Wavelength, the 2.4 gigahertz has a wavelength of 5 inches. The wavelength is the crest and the trump. Okay, now it's got 5 inches, and the 5 gigahertz one has the wavelength of 2 inches. So basically we always prefer for the 2.4 because lower the frequency, the larger is the wavelength. And the larger is the wavelength, the less is the attenuation, which is the loss of the signal. And that means the better is the penetration through walls and so on. So if you go for a 2.4 gigahertz kind of signal where the wavelength is higher, okay, larger, that means that the attenuation or the loss of the signal will be less and the penetration will be higher. Security. In security aspect, Wi-Fi has got a framework that called EAP, or the Extensible Authentication Protocol, and that's the framework within which it is being used to authenticate the end users or the wireless users. Now, you might have heard about 802.1x. So 802.1x is basically a system that will run a piece of software. That software is called a supplicant. Now what happens is that when from the end user you are getting connected to Wi-Fi, then the authentication is going to happen with that help of that supplicant software, and you need to have a separate authentication server with the help of which the server will say yes, the password is correct, and now the user will get connected to the Wi-Fi. Okay. When it comes to the protocols of security in Wi-Fi, then we have got WPA1, 2, and 3. WPA3 is currently the most widely used because it came up like in 2018, and that's got 128-bit encryption in personal Wi-Fi mode and 192-bit encryption in enterprise mode. All right, so that's the key points about wireless, and in the upcoming lab we are going to see how the wireless will be set up along with the security protocols and how we are going to verify or validate between the Wi-Fi and the wired and so on. Welcome to Wireless Lab. So the steps that we are going to perform in the lab, they are being jotted on the left hand side. We have got close to 9 steps followed by the verification steps. So step number 1 is that we are going to design and power on the devices. And we are going to ensure that we are going to have a WLC or a wireless controller configuration through web. Now a wireless controller is something the central focal point for all the access points. If you have got, let's say, multiple floors in a building and you want to manage all the access points in all the floors, or to ensure that they all are working fine, uh, you do not need to go to each floor to each of the access point. You can have a centralized wireless controller through which you can monitor the traffic, and also you can maintain the access points. All right. So in this particular lab, let's bring up the devices. Let me go ahead and first of all get a wireless controller. Let me get 2504, which is right here. And we also need a switch because that will be working through the switch. So we get a switch here. And we also need some access points here. So here in packet tracer, you will see them. They're called LAP. And let me just grab a few of them. Probably one. I think we should be taking 2. Let's take one more. 3. Okay. Lightweight access points, or LAPs, right? And we are also going to pull up a server that's called a DHCP server, just to ensure our DNS and the default gateway, they are all configured automatically. Now, once this part is done, let me go ahead and name them. I will just name them quickly, like LAP1, LAP2, and this is LAP3. Okay. Once that's being done, then I'm going to connect the devices. So let me connect the WLC to the switch, server to the switch, and from the switch we're going to connect all the APs, AP1, AP2, and AP3. Okay. We also have to rename this. We will just mention WLC, and this is how it should look like. Probably let's bring it here. Okay. Okay. So power on the devices, you will just see that this part is like red. The remaining all are powered on. So I will just power this APs as well. All you have to do is that you have to get this particular power cable and connect it there in the physical view. Okay, and it's powered on. Similarly, this one as well. And similarly, this one as well. Okay. Let's give the IP address here. We will give it here as, I will keep it the subnet mask as /24 for all the devices, and default gateway I will give 1.1.1254, and DNS we will give as I'll just name the DNS. DNS will be 1.1.1.2. Okay, that's how it is. WLC, I will give the IP address as 1.1.1.1, and that's about it. So design and power on is completed. Step number 1. Step number 2 is IP and DHCP server configuration. So first of all, let me go to DHCP server. and let's go to desktop and configure it. So this should be 1.1.1.2. Subnet mask /24 I have kept. So dot 255.255.0. Default gateway I'll be keeping 1.1.1254, and DNS server 1.1.1.2. Okay. Now once that's been done, then I will be getting into the services, and I will go to DHCP here, and I will turn on the DHCP service. Default gateway, I will give it 1.1.1.254. DNS server, that is 1.1.1.2. Your start IP address, let's say I will start from 55 users, so I will start from 51 maybe. And subnet mask 0, fine. Number of users, I will keep it as, let's say, 155. TFTP, nothing is there. WLC, or the controller address, is 1.1.1.1. Okay, and I will click on save. So your entire details are coming up here: default gateway, DNS server, starting IP, subnet mask, user, and WLC. Okay, so configure the DHCP server. Now WLC I have to configure. Config settings. We go to management. In the management, I will type in 1.1.1.1. Subnet mask, this will be .0. Default gateway 1.1.1.254, and DNS server 1.1.1.2. Okay, so we are done with WLC configuration. Now it tells that connect management PC to WLC and IP configuration at PC. Basically, if I want to configure the WLC, I need to have a laptop connected to it, which is called the management PC. I can keep it here. And let me connect that to the WLC. Got connected. And we are going to keep a IP address there for the laptop. That can be 1.1.1.10. Okay. Let me go to the laptop and configure it quickly. 1.1.1.10. Subnet mask 255.255.0/24 is there. Default gateway 1.1.1.254, and DNS server 1.1.1.2. Okay, this part is completed. Now it tells that access WLC through browser for initial configuration. Okay, so I will go to my laptop and I will access the WLC through the browser. I will go to the web browser, and the address here will be 1.1.1.1, right? That is the address of the WLC. Press enter, and it will take a little bit of time, then it will come up with the landing page for the WLC screen. So I hope you got the configuration or the topology here. Very simple. From the laptop, from the management laptop, we are going to configure the WLC with the help of the browser. And the WLC is connected to the switch. Switch is having 3 APs connected. And we have got a DHCP server also connected to the switch. So that is the page which I was trying to show. It will be coming up here. And now we have to enter this page, create admin username. Let me just put in admin there. Admin password, probably admin at 123, just a dummy password, and at 123. Okay, start. So we are enter. Now it asks about enter a name for your new system. We'll just name something like CCNA WLC. Okay. Country, date and time, all is fine. Now management IP address that you will keep there as 1.1.1.1. Subnet mask 255.255.255.0. Default gateway 1.1.1.254, right? And click on next. So this is the initial setting up of the WLC with your HTTP browser. Just the basic stuff will be given here. Network name, let's give a network name like CCNA. Okay. Security, here is the point. You can drop down and go for the personal or the enterprise. I will choose the personal here, just as a choice to show you. Passphrase, we have to give a password. I will give CCNA at 123 and confirm the password CCNA at 123. Okay. Now again, click on next. Keep all the same, don't have to change anything. Set up your controller, create a wireless network, all done. Advanced settings, virtual IP, all fine. Click on next, and now it's asking in that please confirm the settings and then apply. So username, admin, system name, country, management IPs, gateways, you've given all of them, right? Security, and then you just have to click on apply. System will reboot, click to apply. If you click on OK, the system will start rebooting and your uh, apply or the settings will be change effect. Okay. Um, while it is doing that, will take some time to do that. While it is doing that, let's do the other thing it's asking, which is number 6. So 5 we are done. 6 is access the WLC through browser. Now with the help of HTTPS. Okay, no longer like HTTP, but HTTPS. And we need to also check if the access points are configured properly and create the SSIDs. Okay, now SSIDs are nothing but your wireless network name. Your wireless network names are called SSIDs. So we will be having 3 names here like CCNA, NP, and IE, and I will show it to you. Okay, so this time let's go back to laptop and let me go back to, hold on a second, browser, and we will go to https://1.1.1.1, enter. This is, oh sorry, HTTPS I should have typed in. Something wrong is going on, give me 1 second. https://1.1.1.1. Yeah. Once you do that, then you get the wireless LAN controller login page, and I get inside there. So the initial was through the browser, just a normal browser, okay, with your port 80, and there you go ahead and do the initial setup of the WLC. Okay. Now for the advanced kind of the settings, and also to ensure that your APs are getting properly configured, you need to go through the HTTPS connection. So your username is admin and the password is admin at 123. Login. Once I log in, then you will see all this details in the home page. Here you will see the management address, the version of the software, uh, all the details will be showing up right there. Okay, and the access points are showing like 0 right now. So let's go to WLAN from here. Once you go to WLAN, there you will see the SSIDs which are showing up. So the first one which is showing up is your CCNA. Okay, we will create 2 more just to ensure that once we connect our wired devices and the wireless devices, they all get connected and the connectivity can be checked on the wired and the wireless through multiple SSIDs. Okay, so create new, click on go, and I will be creating a profile. WLAN it is. Profile name, let's say CCNP this time. SSID, let's say CCNP, and I will say apply. Once I click on apply, then we have got all these options coming up. Status will be enabled, and then you click on apply again. Okay, then go back to the security. In the security, all you have to do is that layer 2, click on the drop down and choose WPA plus WPA2. So WPA3 is the latest one, which is supported on the latest controllers. But currently on the controller model that we are using, that is having only WPA or WPA2. Select both of them, and I will not go for the WPA, but I will go for WPA2 policy. Select this one, the latest one. And once that's being done, now 802.1x, that is a part of the EAP framework, which means that you need to have a supplicant software through which you need to have a separate access or authentication server which will ensure that your passwords are correct. So we don't have that, we don't need that. We are just going to go for the PSK, the normal password situation. And if I go for password, then it will ask you to type in the password. I will say CCNP at 123. Okay. Once the password is done, we are completed with this, click on apply. Changing the parameters, say okay, and it will come up in a moment. Okay, done. If I go to WLANs on the left hand side, you will see that both your CCNA and CCNP are showing up here. We'll create one more. Like I said, I want to create 3 SSIDs here. So I will create CCIE and CCIE again, apply. Now again, the same process, go for enabled, apply, and then go for security, WPA plus WPA2 you select, WPA2 policy you select, and this time again under PSK, you type in the password. This password, I will keep it simple, like CCIE at 123. Okay. Scroll down and we are done with this. So click on apply. All done. It will take a moment to just establish. We are completed by creating the SSIDs, okay, the WLANs. So 3 of them are there, CCNA, NP, and IE. Now, once this is being completed, then we are going to go to this security tab on the top, which is this one. Okay, just to have a quick check. Security is showing fine here, and sometimes you just will be seeing that all are like kind of grayed out. Then you have to click on the refresh on the top. It will come back. Let's go to wireless now, and in the wireless you will see the access point. So currently the access points are showing as 0, but we have got 3 of them, right? So we need to configure them. Let's go back to the access points and let's go to config. I just want to use my DHCP. Let's see if that works. And it's working. Great. Let's pick up the next one. Config. Static, I will change to DHCP. Works fine. And the last one. So here also I'll change it to DHCP. And this also works absolutely fine. So our Wi-Fi access points, they are showing the proper DHCPs. Now let me go back to WLC, not this one, sorry. We'll go back to the controller page and click on refresh. And let's see, it's coming up, right? All the 3 APs are showing up here, right? So we have got the LAP or the AP1, which is 51 IP address. Number 2 is 52 IP address. And number 3 is 53 IP. It's taking in a very sequential way because the DHCP server is configured in that fashion. Also, we are seeing the AP model number, the AP MAC address, and the uptime. So you see from the DHCP, I mean from the controller itself or the WLC itself, we can have a complete view of the APs and we can troubleshoot them, we can monitor them, and so on. We don't have to go to each of the APs to find out what their IP address is, right? Now that being done, let me just close this. Okay. Now it's asking that check the APs and create the SSIDs. So now in each of the APs, I'm going to go and I will just ensure that the SSIDs are properly mentioned there. 1 second, not this one. No, that is being done in this case. Hold on 1 second, just I will check it up once more. Okay, fine. They've came up fine. Sometimes they're like grayed out, so just double check them. So SSIDs is done in the WLC. The access points are having the DHCP and the DNS details, the default gateway details as well. So all is correct. Now create the AP groups and define APs for each group. So what we have to do is that I will pull up some smart devices, okay? So let me go ahead and pull up some smart device. and do some wireless connectivity. So pull this one, let's say a smartphone, here, here, and here, three of them, right? Once we have picked up three of them, then I will be going into each one of them and I will go for the connectivity. Now there is an option there called the option number 8, which talks about press fast forward. Fast forward is basically this option, this button here. In the simulator, sometimes what happens that your update will take a long time, or it's not working, or got jammed up. Like once in a while, it might happen. If that happens, and you know that it's going to take like 40 seconds, but by 40 seconds also the update is not happening, then you just have to press the fast forward once to ensure it goes fast, and it should be connecting or going to the next step once you click on the fast forward. So we have not used it till now because I think things are working well and fine. We probably don't have to use it. Let's go to smartphone. And in the smartphone, I will go to wireless and I will set up the smartphones. SSID, I will give CCNA, first one. And here I will give the password WPA2PSK. This will be CCNA at 123. Okay. Now, once I give that, then you will see this smart device will be connecting to one of the APs. Look at that. It got connected, right? Wirelessly. Similarly, I will go to this smartphone and I will connect that with the next SSID. Let's say I give CCNP and here WPA2, and I will say CCNP at 123, right? And this also will get connected. All right. And let's go for the last one. Come to wireless, and again this time you type, the last one was CCIE, and let's type in the password CCIE at 123, and that also got connected. So um, we are done with the connection. So sometimes your Wi-Fi connectivity will not be happening or things will be slow. In that case, just press the fast forward this button here and things will be working. Like I said, once in a while in the packet tracer, things might get jammed up a little bit. Not always, but once in a while. If that's the case, just follow the steps here, and step number 8 will be fast forward. Just do that, things will be sorted. Okay, so your configuration of the client is done. Now we are looking at a particular wireless setup where the wireless controller is set up, our management laptop is set up, our DHCP is completely up and working, our APs are up and working, and these smartphones are connected to the APs with the help of Wi-Fi SSIDs, right? So now we are going to do the verification. Verify number one, but before the verification happens, I would like to connect a few more devices to ensure that we can verify it properly. So what I'm going to do here is that, let me just take this guy here. Okay, all right. I will connect a router also. Uh, and I will just keep it as a default gateway. Um, all right, this is the router. Just name it R1. And let's take the connection from the router to the switch, right? Once that connection is done, then I'm going to give the router the default gateway address. So let me quickly do that. And the interface is G0/0. So make it no. Enable, sorry, this will take some time because that was a wrong command. While it's doing that or correcting it, see, the aim is that why I'm keeping the router here, this is just to ensure that assume it is a ISP router. And if the smart devices or the smartphones can connect to the router in the default gateway, then definitely they can connect to the internet as well, because the other end of the router will be connected to the internet. And if the smartphones can connect to the default gateway of the router, that means they can connect to the internet as well. Okay, that's the whole reason I'm trying to put a router and check if the connectivity works. It will take some time to come up. In the meanwhile, let me go ahead and pick up two laptops. for the wired connection check. Okay, one here and one here. Now these laptops, pretty simple. I will just connect them to the switch like this, and from here to here, connect them. Okay. All right. Now in this, let me just configure it. Okay, we have got the router back. Enable. So once in a while it might happen, then you just wait for 2-3 minutes and it will again come back. Okay, so config hostname R1, and I will say interface gig 0/0. IP address will be 1.1.1.254. Sorry, dot 254, and subnet mask 255.255.255.0. All right, just say no shut, and we are done. Okay, so that's about the router, and this interface should be coming up in a moment. It is not up yet. It should be up in a while. Okay, let's keep it like this, probably. Yeah. Now coming to the laptops, let me just go ahead and give them some IPs. Config. Let me go to the configuration piece. If the DHCP works fine, it's great. Okay, 58, we got it. And what about this one? Desktop, IP, and DHCP. 59. Okay, so this is 59 and that is 58. I just mention it 1.1.1.59, and this is 1.1.1.58. Okay. Now this particular devices, we have got the IPs. What about the IPs of these guys? Access point is this one 51, this one 52, and this one 53. Let's type in that 1.1.1.51, 1.1.1.52, and 1.1.1.53, right? Okay. And the smartphones, these are having IPs 56 followed by 54 and 57. So this will be 1.1.1.56, 1.1.1.54, 1.1.1.57. Let's see how it is. Just double check. This is 56 and the next one is 54. Done. And the next one is 57. Cool. So completely being set up, and now I'm going to check the connectivity. So first thing is that I will check the connectivity from the Wi-Fi from all the smartphones to the wired connection, like to the laptops. Okay, so let's go to the smartphone and command prompt ping. What is the laptop? It is 11158, right? 11158. Enter, and the ping is working absolutely fine. What about the next laptop? That is 59. Let's check it out. That also works fine. Super. So we have got the connectivity between the smartphones and the laptops. Now, what about the smartphone to the router, the default gateway? Is that working? 254? That also works absolutely fine, which means the smartphones can get connected to the internet as well, because that router we have considered as the ISP router. Okay. Now we are going to check the connectivity between wired and wireless. Okay, there is a spelling error there. I see. Let me just correct it. Wired and wireless to default gateway. Let me just get it like this. 1 second. For some reason, I'm not able to get connected to that page. Wireless. Okay. All right. That's perfectly fine now. So connectivity between wired and wireless to the default gateway. So we have checked the wireless to the default. That works absolutely fine. What about the wireless? So from laptop, we are going to now check the connectivity to, first of all, the default gateway 1.1.254. Does that works? Yep, that works absolutely fine. And then what about the laptop to the smartphone? Let's say from this laptop to the smartphone, 11156, or let's say 11154 maybe, 11154. That works, right? Similarly, from this laptop, from 5.9, we can check if this works 1.1.1.254, and that too works absolutely fine, right? From here, we can check 5.7, the smart phone, absolutely works fine. So right now we are seeing that all the smartphones are connected over the wireless, and they can talk with the wired devices like the laptops, and also with the default gateway, which is important because if the smartphones wants to connect to internet, it's simple for them. If they can reach out to the default gateway, then definitely they can reach out to the other hop as well. Um, for the wired also, we have seen that they can connect to the default gateway, and they also can connect to the smartphones. So absolutely works fine. Just try it out once because there are multiple devices here and multiple ways to configure them. So remembering it will be difficult. So try it once or twice on your own packet tracer and things will be simple. All right, with that we came to the end of the wireless lab. I hope you enjoyed it. Cheers.